I heard you liked math and chemistry, so bam, here's some math. Talking about that molar mass. Molar mass. Well, molar sounds like moles. I know, right? Mass sounds like mass, like grams, I guess. So let's read this. What's it say? Besides volume, okay, volumes like liters and stuff, most of the units used so far in this course are very difficult to measure in the laboratory. Okay. The unit that's easiest to measure in the lab is mass. So, like grams. The molar mass of a compound is the number of grams in 1 mole of the chemical. So number of grams in 1 mole of the chemical. So that's a definition for a vocab word right there. Seems important. This ratio, it's a ratio, can easily be used in conversions. So does that mean it's a conversion factor? Conversions, question mark, conversion factor. Molar mass is calculated by adding up the molar masses of each element, which can easily be found on the periodic table. Hold on, let me look at my periodic table. What is this saying? Okay, we got like this, the atomic mass. So this is also molar mass for the element. I mean, that's the only mass on here, so it must be. Let's look at the examples. How many grams of hydrogen peroxide, so we're looking for grams, are contained in 3 moles of hydrogen peroxide? So I guess the first thing they do is they find the molar mass, because H2O2 is not on here, but I've got H right here, I've got O right here. So they do 2 times 1, because H is 1 gram per mole right there. And then plus 2 times 16, because O is 16 molar mass. So what is that? 2 plus 32 is 34. But that's just to find the conversion factor, right? Because I see down here it's going to be the conversion factor. So they haven't even converted anything. That's just to set it up. So we go 3 mole H2O2, mole H2O2 on the bottom, grams on top, because we're looking for grams. 3 times 34, boom, goes the dynamite. Okay, alright, so moles to grams, you just multiply by the molar mass, basically. Find the molar mass by adding it up on the periodic table. Alright, number 2, how many moles of water, so now we're looking for moles, found grams before, were there if the reaction started with 27 grams of water? So now I need the molar mass of water. This is a little different because it's got a 1 here. So it's not always a 2, because this subscript is a 1, I guess. So it's like this subscript goes here, this subscript goes here, and the mass of each element is like next to it. So 2 times 1 is 2, plus 1 times 16 is 18. 27 grams. Grams goes on the bottom. So it looks like the molar mass always goes with the grams. Huh, interesting observation. You can steal that one if you want. So then 27 divided by 18, 1.5 moles of H2O. Okay, make some observations. Be ready to discuss in class. Molar mass. Man, we have so many conversion factors. This is exciting. I wonder if we could use them at the same time. That would that'd be just too much. Too much.